Okay, I'm going to just go off my sketches and my pencil work this time because I'm running a little bit short on time, so I just want to get these in so you'll have access to these, but I think you'll be able to follow them. Again, this is homework number, this is 7.3, number 18. And again, I drew my sketch, and please make sure you're drawing sketches and try to label your axes and try to make them as neat as possible because it does make a difference in, your awareness of what's going on. So we have the two curves. We're trying to find the volume generated when we take the region that's bounded by these two curves, y equals 4 minus x squared, and y equals 2 minus x, and we're going to take this bounded region and we're going to revolve it around the x-axis. This is what the reflection looks like after we've revolved it 180 degrees. So it looks something like this. And again, we're going to have a hole here, so we're going to use the washer method. So first of all, we have to find out where they are going to intersect, so how we're going to integrate. And remember, this is going to be around the x-axis, so we're going to be integrating with respect to x. So we'll be using these vertical discs. They'll be going like this, actually vertical washers. So in order to find the points of intersection, I just take the one curve, which is 4 minus x squared, and set it equal to the second curve, y equals 2 minus x. They both equal y, so we set them equal to each other. And then we just simplify. When we simplify, we end up with x squared minus x minus 2. And then we factor that. That's x minus 2, x plus 1. So we end up with x equals negative 1 and x equals 2. And that's where I'm going to integrate from. So that's where they intersect at negative 1 and at 2. And we just have to follow our pattern. Now, again, this is going to be the top curve. And this will be the bottom curve. So I'll bring it over here so you can see it. So again, we set this up. Volume equals the integral from negative 1 to 2, and then this is my general form, pi big R squared minus pi little r squared dx. And then I brought out the pi. So I've got the integral from negative 1 to 2. And this is going to be my top curve minus the bottom curve. Again, this is the top curve over here. Okay, 4 minus x squared, and this is the bottom curve, 2 minus x. And then after that, it's all mechanical, very similar to the earlier problems we did in the previous assignments. So this becomes, we have to square this out. I've got my pi out there. So this becomes 16, okay, minus 8x squared plus x to the fourth. Minus, and this becomes 4 minus 4x plus x squared, all dx. Make sure you're showing all this work, please. Some people are skipping the work. Make sure you show all that. And then volume equals pi, and then the same integral, and then we're just going to simplify this out. So I remove the parentheses, 16 minus 8x squared plus x to the fourth, negative 4, positive 4x, negative x squared. And when I combine like terms, we end up with x to the fourth minus 9x squared, negative 8x squared, and negative x squared is negative 9x squared, plus 4x, and then 16 minus 4 is 12. Then we're ready to take the antiderivative. So that's just the volume equals x to the fifth over 5, 9x cubed over 3, 4x squared over 2 plus 12x, and that's from negative 1 to 2, so we don't have any symmetries. And you can see here this is volume equals, and I started to simplify, so actually I substituted into, so I got 32 fifths minus 24 plus 8 plus 24, and then I substitute the negative 1 in, I get negative 1/5, ends up being positive 3, positive 2, negative 12, and then I simplified, combining everything. So that I've just simplified over here. We ended up with the 24s cancel, so I had negative 32 plus 8, and I combined over here, and I had negative 1/5, and then 3 plus 2 is 5, negative 12 is positive 7. We simplified over here, and we got 33 fifths plus 15, pi times that, of course. Pi times 33 over 5 and then 15 would be 75 over 5, then I end up with 108. Sorry about that. I'll repeat that. So I had 33 over 5 plus 15, and that became 33 over 5 plus 75 over 5, that's 15. That ends up being 108 over 5 pi. Now, make sure you can go through all these calculations and you get the correct answer, because you need to be good on your arithmetic. Okay? Number 19. Again, I drew the sketch. Now, this was a little trickier because this was the secant, and this was the region bounded by the secant of x and y equals the square root of 2. So remember, the secant, the cosine goes like this. This is 1, and this is pi over 2, so the cosine in this region goes like this, and it's equal to 0 at pi over 2, negative pi over 2, so the secant will be asymptotic to that because it's 1 over the cosine, so it's going to be 1 over 0. So these will be asymptotes for the secant, so the secant approaches that. So I want to see where my intersection is, so I just set the secant of x equal to the square root of 2. It was y equals the secant of x, y equals the square root of 2. So I just set those equal to each other. Now, the secant is 1 over the cosine, so I could kind of reverse these, and I get the cosine equals 1 over the square root of 2. And then I can just rationalize this, so I get the square root of 2 over 2, and the cosine equals the square root of 2 over 2. That's positive in the first and the fourth quadrant, so it's going to be positive and negative pi over 4. So that works out really nice. So this was my intersection, and that's what I'm going to integrate from, negative pi over 4 to pi over 4. Now, this is my top curve, the square root of 2, and the bottom curve is the secant. Top curve, bottom curve, and again we're going to be using, I didn't draw the reflection over here, but we're going to be using a vertical disk. So top curve minus bottom curve, I'm going to rotate this all the way around, the x-axis. So my general form over here, here's number 19. So the integral from negative pi over 4 to pi over 4, and then pi times big R squared minus pi times little r squared dx. So again, this is my top curve, squared, and bottom curve, squared. And that was the square root of 2 squared, and that was the secant squared, or the secant of x squared, because that was the bottom curve. So if I square the square root of 2, I get 2. And if I square the square root of if I square secant, I get secant squared. And then I'm ready to take my antiderivative, and these work out real nice because the antiderivative of 2 is just 2x, and the antiderivative of the secant squared is good old tangent x. So that worked out real nice. And again, I have the pi out in front, so I've got pi. And then I evaluate both these, so I've got 2x at pi over 4, that becomes pi over 2, and the tangent of pi over 4 is 1 minus, and then if I put negative pi over 4 into x, I get negative pi over 2 minus, and the tangent of negative pi over 4, that puts it in the fourth quadrant, so that's going to be negative 1. Then I can simplify this all out, pi times, so I've got pi over pi times, and I got pi over 2 minus 1 plus pi over 2, that's a positive, and another negative, negative 1. So it ends up being pi times pi over 2 plus pi over 2 is pi minus 2, and then I can multiply this out, and I get pi squared minus 2 pi, which is the way the answer was in the book, I believe. Okay, so not too hard once you figured out the sketch.